like we'll go in order from A to F. I cannot go in reverse order because the session is going to get uploaded on the YouTube. So anyways, this is the first problem. Like for the starting problems, I'll just quickly go over them. And for the problems that are ahead, I'm going to give them much more time. But in case you have doubt, let me know. It's not like I'm not going to discuss these problems in detail. Okay. So this is the first problem. And this problem we are given that we have, first of all, let me start my screen share. So this is the first problem. And in this problem, first tell me, is my screen visible? Yes,
Yes.
no, anything? Okay.
Yes.
And is there any lag in my voice?
No.
No lag.
Okay. In case if you feel at any point that my voice is lagging or my voice is low, let me know. So this is the first problem of today's contest. And in this problem, we are given that we have an array consisting of n integers, and our task is to determine whether it's possible to color all its elements in two colors in such a way that the sum of both the elements, of both the colors have the same parity. So by same parity, we mean if the sum or like once we color these elements, okay, so let's say there are these elements and we divide these elements into two parts. So once we take some of these elements, if this comes out to be odd, then this should also be odd. So, and if this is even, then this should also be even. So this is only possible when the sum of, like the complete sum of my array is what it should be.
Even.
Yes. Okay, someone is saying screen is not visible. Is this the case for everyone?
It's visible. It's
No.
visible.
Okay. So the sum should be even. So we can simply check what is the count of odd elements. See, if odd elements appear odd number of times, my sum is going to be odd. Otherwise, it's going to be even. Or you can simply find the sum also. Both of these will work. So first of all, let me know, is anyone having any doubt in this? Yes, no, anything?
Sir, this got disconnected.
Could you explain why we are counting only odd elements?
Okay, see, if the like the count, you don't have to actually count the odd elements. It's one of the ways to find what is the, like the final sum is going to be odd or even. See, you understand if sum is even, then the answer is yes. Otherwise, the answer is no. Yes, you get this part, right?
Yes.
Because n is more than 2, you have to make sure that if n was 1, then it was possible. Like in this case, n is more than or equals to 2. So I'm directly checking sum. But if n was 1 and sum was even, then also then there is no point in dividing because the second array will always be empty. But since n is more than equals to 2, we just have to check sum is even and sum is odd. So you get the idea why I'm checking sum. Now you just have the doubt why I'm checking the count of odd, right?
Yes.
See, if count of odd numbers, this thing is also odd. This means I have something like 1, 1, 3, 3, 1. So, and then there are some even elements. So some of these even elements, they occurs x times. So x times the all these even numbers, the sum is going to be even only, right? And these odd numbers, since their count is odd, this will be odd. The sum of these will be odd. So even plus odd is also odd. So that's why it's like enough to just count what is the count of odd numbers.
See, the count of odd numbers is, let's say, even. So that will be parity.
Then if count of odd numbers is even, then the sum of all of these odd numbers will also be even. Now even plus this even is also even. Is it okay? So answer is yes.
Yes, I'm clear.
Yes, way. Clear way.
Okay, so I'll quickly go over through the code. So this is the implementation. I didn't find the sum, but found the number of count, what is the count of odd elements. So I'm counting those elements, and if this turns out to be odd, answer is no. Otherwise, the answer is yes. So just write in the chat. Can we go ahead? Okay. So coming to the second problem. So this is the second problem. And in this problem, we are given that we have a natural number x and we can perform the following operations. So we have to choose a positive integer k and round x to the kth digit. Now, this is just telling us that the positions are numbered from right to left. So starting from 0, if the number has k digits, it is considered that the digit at the kth position is equals to 0. Then the rounding is done as follows. So this is the basically the generic rounding. So if the element at the k minus 1 position is greater than or equals to 5, we increment it by 1, otherwise we make it 0. And if it was a 9, we'll add 1 to the next element. Okay. Then after that, we all digits which positions are less than k are replaced with 0. So this is the general rounding, how rounding works, right? So basically, if you have 3541 and we do rounding for this digit, so we'll get 3450. Why? Because this 1 is less than 5. Then for this 5, since this 5 is more than, like this 5 is more than equals to 5, so we'll increment the next digit and make all of these 0. So what our task is, for each set of input data, we have to output the maximum possible value of x after the operations. And the number should not have any leading zeros in its representation. So first of all, tell me, has like everyone understood the question?
Yes.
Quickly repeat what you said.
Okay, we just have to.
Exactly. Like, can you just go to the question again? I did not understand the question. And if you can
Okay,
just go
okay,
through it again.
okay, I'll explain you here. See, we are given a number x, or maybe let's write this as s. So we are given a n digit number. This n digit number can be like the n is less than or equals to 2 into 10 to the power 5. So first of all, we have an n digit natural number, and now we have to like perform some rounding the kth digit. So like for k equals to 1, we have to go from k is equals to 1 to n, and each time we'll perform the rounding on that kth digit. So let me tell you how this works. So this is the 0th digit, right? If you have 1, 2, 3, 4, 5, okay, let me write something else. If we have something. Okay, so someone is asking what's the significance of saying it's less than, it's given in the problem statement that the size of this is less than or equals to 2 into 10 to the power 5. So what we are given this number, and suppose the number was 1256. So this is ones digit, this is tens digit, this is hundreds digit, and this is the thousand digits, right? Now 0, 2, 5, 4. Similar, this is the ones digit, this is tens, hundreds, thousands, and this is 10,000 digit, right? So basically we'll start from here, and first we'll try to round off this 0th ones digit. Then we'll try to round off this tens digit. So how does rounding work? See, if this is a 4, if this is less than, if the digit is less than 5, we'll make it 0. If it is, okay, let me write this again. If the digit is less than 5, we'll make it 0. If the digit is more than or equals to 5, we'll increment it by 1. In case this was 9, we will make it 0, and we'll increment the next digit. So is the problem statement clear? Now we'll do all of these operations, like we'll keep rounding off from here to here, and at any point, like we'll try to get what is the maximum value that we can get after each of these rounding off.
Excuse me.
Yes.
I have a doubt. Like, it is given over here that if the digit at k minus 1th position is
Yes.
greater than or equal to 5, then the digit at kth position will be increased
Yes.
by 1.
So according to like what you're trying to do is you are taking these as the digits, right? 0th digit, first digit, second digit, third digit, but this is the normal indexing for this string or maybe an array. But here you have to take this as your 0th digit. This is your first. This is your second. This is your third digit. Do you get it? So if this is k,
Okay.
this is k plus 1. Or if this is k minus 1, this is k. So if this was 9, and when you're trying to round off this will get increased by 1. This is how rounding off works. Don't get confused by the problem statement. Do you get it?
Yes. Continue.
Okay. So someone in the chat wrote that my audio is low. Is this for everyone?
No, it is
No.
fine.
It's fine.
No,
Okay. So now is the problem statement clear to everyone?
yes.
We will see the kth digit and then increment the k plus 1th digit, right?
Yes.
Right?
In case the kth digit was 9. Otherwise, if it is more than or equals to 5, we'll just increment this. Like if this is more than or equals to 5, we'll increment this digit. In case this was 9, we'll make this as 0 only. Like we'll increment this digit when the digit at this place is more than or equals to 5. In case this is less than 5, we'll just make this digit as 0 and we won't increment this digit. Basically, this is what you do in your when you're rounding off a number, right? What is the
What
round?
about the remaining digits? What about the remaining digits?
So we are
Before
already
this.
coming from this place, right? We are already coming from this right to left. So all of these digits after this place will always be 0 only, because we have already rounded off those digits. Like you look at this example. So this was the original number. When k is 1, we get this thing. When k is 2, we get this thing. When k is 3, we get this thing.
Understood.
So, is it clear now?
This
Okay. So now see, this problem is very simple. Since we are going from this place to, like, we are going in this direction, we have to just find what is the maximum. Like, see, if we are rounding off this thing after like this digit, we'll have only zeros, right? But if we are rounding this thing, this digit will get in, probably this digit will get increased by 1. If this was more than equals to 5, right? This digit will get increased by 1. So it doesn't matter what we did here. Since this digit is getting increased by 1, it is always beneficial to stop k here rather than anywhere here. I'll take one example. Okay, but first of all, understand this. If I round off this thing 5, see what in the problem statement, what I'm given? I'm given a string s. I'll start rounding off from this side and I have to stop after some k. And that means I would have rounded off all of these digits and I have to give the answer as maximum. So I have to stop my k from this, like I'll start from this place and I have to stop my k somewhere in between. And I'll say that this is the maximum number that I'll get. So I'm saying if it's possible to round off this digit, stop your k here, not here. Why? Because if you round off this digit, maybe this element will get incremented. So this is basically more. So you just have to find what is the earliest or what is the leftmost position at which you'll get more than or equals to 5. A digit which is more than or equals to 5, you'll stop your k there. So basically at that point, you'll increment your value by 1 and you'll make all of the rest zeros. So is this thing clear?
But what if after finding this, because of finding this leftmost five thing, after increment, after I round off, then some even more left digit becomes equal to 5 or greater than 5.
Yeah, so you'll keep, like, I'm just saying you, okay, I'll show you the code for that. So first of all, is this thing clear to everyone?
Can we go through it quickly, like once more?
Okay, see, you just have to find a position, like you just start doing your rounding off from this side. And if you find that the digit is more than or equals to 5, you just increment the next digit. And this way you'll keep on continuing and find the maximum position at which, or find the leftmost position for which you are incrementing your the next, I'm calling this next, this left digit next. So find the leftmost position for which you are incrementing your next digit, because it's optimal to stop at that point. Why? Because if you would have stopped anyway before this place, then this digit, if this is 2, it would remain 2. But now if you stop at this place, this will become 3. So did you get the idea? So you just have to find the leftmost position such that after
This
rounding
digit
this
was,
thing, what?
what if this digit, what if this digit was 4? Then after rounding off, it becomes 5,
Yeah,
and then
yeah.
again we have to go.
So no. After rounding off, if this digit was 4, after rounding off, this doesn't change. This becomes 0.
No, the other one, below this
Okay.
3.
If this was 4
4.
and there was some digit more than equals to 5 here, right? So after rounding off, this will
Yes.
become 5. So make your k
Yes.
come here. You'll round off till here. So after this point, or maybe like even this point, everything will be 0 and this will be 5. This is the maximum that you can get.
But we'll have to go even further to see check all the
Yeah,
digits.
you'll check for each and every digit.
Okay.
See, just keep in mind what rounding off means. I think you're getting confused by the problem statement. Rounding off is simply if the digit is more than equals to 5, it will like anyway this digit will become 0 only, but the previous, not the previous, I'll call it as next, the next digit, which is like 10 times more than, like if this was once, it is tens digit. If this was tens, it is hundreds digit. It will get incremented by 1, right? So just keep in mind that if you are incrementing the left, like a left digit, the value of the number is more. So just you have to find the leftmost position, which you will round off. Is it clear?
Sir, can you explain for test case 204445?
Okay. 20445, right? C.
Yes.
So if you'll round off this, what will you get? 20450. So okay, make your k come here. Now, if you'll round this, what will you get? 20500. So make your k come here. Now, when you round this thing, you'll get 21000. So okay, make your k come here. When you'll round this, you will get 20000. So now, since after rounding this, the next digit didn't get increased by 1, didn't get incremented, your k will be still here only. And again, round this. So after rounding this, since this is less than 5, your thing will become 00000. Now again, the next digit didn't get increased by 1, so your k is still pointing here. So this means you have to make all of these digits 0, and you just have to increment this by 1 in your original problem. So your answer will be 2100.
Okay, sir.
So is this thing clear to everyone now?
Yes, sir.
Okay,
Yes.
I'll quickly show you the code now. So this is the implementation. First, see, I'm just adding a 0 because it's possible, like in the case of 99, my like the total number of digits in my S will increase by 1. So just for that reason, anyways, if like at last I'm checking that there is no 0, but if like in the beginning, just add a 0, and this is the size of n, and zeros is like the point at which I'll stop, k. So now if si is more than or equals to 5, I'll make it as 0. I'll point my 0 to here, like this is k basically where I'm stopping. I'll mark it as k only because that is how I explained this. So now initially k is n, that is I'm stopping after the last digit. And if si is equals to 0, I'll like if si is more than equals to 5, then I'll make it 0. I'll point my k here. And now for all the positions before this, while s of j is 0, I'll make them 0 and I'll keep going back. And finally, I'll increment that digit, which is not equals to 9. Because you can see if you have something like 995 and maybe a 3 here, when you will round this, this will become 0. You cannot, if you add 1 here, this will also become 0. You'll have a carry 1 here, then you'll make again a 0, and you'll add finally 1 here, 4. So you're adding 1 to that point, which is less than 9, right? And all the 9s will become 0. So this is what I'm doing here. Just going back.
K will point where will K point them?
So k is still pointing at I, right? I'm not overwriting
In
it.
that example, that
Yeah, k
3900.
will point at 5 only. This place. And now for going like once I like this loop, I come out of this loop, what I'll do for each of the places from k to n, I'll mark them as 0 like I just showed you. And then if s dot front is 0, that means my number is having a 0 in front of it, so I have to remove it. So this is a simple trick to remove that. I'm taking a substring from 1. I'm not giving the size, so it will take all the elements. The second parameter here is the number of elements, right? If you don't pass it, it will take all the elements. Then
Can
I'm
you
printing
explain this s dot front part again?
Okay, I'll just remove this. This is this thing. Is it okay?
Oh, yeah.
So just write in the chat if you have got this. This is not that hard problem. This is a really easy problem. I think the rating will be around 800 or 900.
What is this last loop doing in which we are traversing from K to N?
Like you have to make all of these like I explained here, right? You have to make all of these. If this is the last position which you'll round up, you have to make all of these 0, right? So that is what is going to happen there.
Can you explain that? Like I didn't get that part. Can you just
Okay,
give one short example of that?
like if you have something like this and you will stop, like you will point out round off till here, you have to make this one also 0, right? So that is what is happening here. My k is pointing here and I have to make all of these 0. This won't be 0, right? Is it okay now?
Sir,
Why you
sir,
are not implementing
sir.
K also?
Hello.
Yes, yes.
Yeah, please explain for 99 as a test case. I have a doubt when 9 comes.
Okay, you have a 99, you increment this, what will happen? This is more than or equals to 5, so you'll increment this. This is 9, so initially I have added a 0 in my string s, right? So you will make this one, this you will make 0, and this is also 0. So now you'll try to change this thing. This is your string right now, so you'll try to make this thing what you'll try to like see that okay, rounding off, but since this is a 0, this won't change anything, and then you'll try to change this thing. So rounding off, since this is less than 5, again anything won't happen. So your k is pointing to only this place. So if your k is pointing to this place, you'll try to make everything after this go 0. There is nothing after this, so your answer is 100.
Yeah, basically the K won't change when this 9 comes.
There is no 9, like I showed you the code, right? There is no 9 after I have made them zeros.
Okay.
Should it not be int j equals I plus 1? Because we are seeing the digit after.
Like this, I'm going in this direction, right?
Yes, we are starting from the last most string. In string, if we are going to the next one, then
So in this, this is next, right? So if this
yeah.
is j, this is j minus 1, right?
Yes.
Okay, so that is what is happening. So just like I think we have already given a lot of time to this. So is this thing clear to everyone?
Yes.
Just write in the chat quickly. I'll share all the codes. You don't have to take screenshots or you don't have to write them down. I'll share all the codes later. Okay, what about other people? I'm not seeing other people responding in the chat. There are very few people. Okay, I think like I'm not sure why other people are not. Okay, I think around 60% have written yes in the chat. So I'll move to the next problem. Okay. So this is the next problem, and in this problem we are given that we have an array A, and so Shasha has an array A, and he got bored. And
Your
for all,
screen is not shared.
okay,
Yeah.
okay. So basically, Shasha has an array A of an integers, and he got bored for. So he got bored, and for all ij, he wrote down the minimum value of ai and aj, and he obtained a new array of size n into n minus 1 by 2. Now, basically, he reshuffled this array B, and now he just asks us whether or not like we can somehow make an array A which satisfies like if we try to get this array B again, so we'll be able to get all these values that are given in input. So basically, see, first of all, if we have an array A of size n, if the array A is of size n, how will we get an array B of size n into n minus 1 by 2? See, for this element, I'll take this element minimum with each of these, right? So for the first element, I'll take the minimum with n minus 1 elements. For the next element, I will take, that is for this second element, I'll take the minimum with n minus 2 elements. So this will continue for all the way till 1. So sum of this is n into n minus 1 by 2. So this is the size of my array B, and it has nothing but minimum of first for these two, then for these two. So this way, and then the array got reshuffled. So first of all, is the problem statement clear? And finally, given this array B, and have to just find an array A from which I can get, like if I do all of these operations again, I can get these values, not that array, exact array, but just the values. So is the problem statement clear?
Yes.
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 Okay. Now see, since in the problem statement, if I show you the problem statement once, see, in this case, it's given to us that we have to find, like, there is no case in which we have to output -1 or anything, right? We have to output any possible array, and by this it means that the answer is always possible. Like we are never given an array of something like we cannot generate this array A. We are not given any of those array Bs. So we are always given an array B from which we can always get an answer. So the best thing is what we can do. See, first of all, we sort. Okay, we actually don't have to sort. Let's just find the count of each element. How many times, let's say this is our array B, we'll count how many times each element is appearing in array B. So we'll count bi for each of these values, and then we'll go in ascending order. Like these are the values, these are the distinct values in our B array or B vector. So we'll go in ascending order, and let's suppose this was the smallest value, this is the smallest value. So how many times would I have taken like the smallest value? How many times should the smallest value be at least there? First of all,
N minus 1.
yes, it should be first n minus 1. But what if there are two, like the smallest value is 0? What if there 0 is appearing 2 times? Then how many times this 0 will come in my array B?
2
N
and 2.
minus
N minus 1
N
plus
minus
n minus 2, right? Yes, no, anything?
Can you explain this again?
See, this 0, you'll take, this is the minimum value, right? So you'll take the minimum with all of these. And since this is the minimum value in your array B, this was the minimum value in your array A by default. So you'll take the minimum of all of these value, this 0 with all of the other values. And since this is some X, this is some Y, this is some Z. So since this 0 is less than all of these values, you'll get this 0 at least n minus 1 times, right?
Yeah. Okay.
So now if this 0 was appearing 2 times, when you will take the minimum of this 0 with again with these X, Y, Z, and maybe other elements, you'll get another n minus 2 times 0, right?
Yes.
So you just have to check, you have to go in ascending order of these, or for all of these unique values in B, and you have to just find, let's say their current element is X and its count is C. I'm going in ascending order. X is going in ascending order of all of the unique values. And in my count of X is nothing but number of times this X is appearing in array B. So this C is nothing but count of X. So what can I do? I can just check while my count of X is more than some number. Let's say this is some number. I'm going to tell you what this number is. I'll add answer dot pushback. I'm going to add this X to my answer, or let's say this is A. This is A. Now, what is this number? What is this number? This number is nothing but this is C. When my answer A size was 0, I was doing n minus 1. When I had one element in my A, I was doing n minus 2. So basically this is n minus 1 minus A dot size. A dot size is nothing but number of elements in A. N minus 1 is this thing. How many times I'll get the minimum. So while count X is more than equals to num, you'll keep doing this thing and you'll decrease your count X by this value num. So this is just simple maths. And finally, for each of the elements, like once you have done this for each and every X, X is nothing but the unique elements in your array B. So finally, you'll get your array A. Is it okay?
Just can you quickly go again? Just repeat the logic.
Yes, we
After
didn't
n
get
minus
it.
1 and minus 2.
I did not get the logic.
Okay. See,
Can you just dry run for some test case?
I'll take a test case. See, let's pick up 1, 1, 3, 1. What is the count of 1? It is 2. And count of 3 is 1. So now, and the unique elements are 1 and 3. So first, let's go over 1, and count of 1 is more than or equals to n minus 1 minus A dot size. A dot size, currently my A is empty. So n minus 1, n is 3 minus 1 minus 0. This is 2. Count of 1 is also 2. So 2 is more than equals to 2. So I'll add 1 in my array A. Now I'll go to 3. Now 3, count of 3 is more than or equals to, again, n is 3 minus 1 minus 1. This is 1. 1 is more than or equals to 1, right?
Able to understand this logic of count greater than n minus 1 minus A dot
Yeah.
size.
Basically, if I'm going in ascending order of unique values, the value which I'm currently taking, how many times will you get this as minimum? And count as the number of times it is actually appearing in array B. So you'll have to like have some kind of imagination for this. If you have the count of each number, like count of BI denotes how many times this value is appearing in array B, right? So like I said, if this was the array A and this is array A and this is the smallest value 0, this will appear at least n minus 1 times, right? The second value will appear n minus 2 times. So if both of these values are same, this value will now occur n minus 1 plus n minus 2 times. So I'm just removing these counts, first n minus 1, then n minus 2, then n minus 3, till the count of BI is 0.
Here
Is it-
BI is the count of that unique value.
Count BI is the how many times, like this is array B, how many times its element, maybe each element is appearing in array B. So if an
Is
element
that
is
for
appearing 5
individual
times,
element or for all the elements present in the array?
like for all, if I had 1 1 1 3 3 2 in array B, so count of 1 is 3, basically count it how many times it is. Count of 1 is 3, count of 3 is 2, and count of 2 is 1.
Okay, got it.
So basically why I'm doing this, see, if you know the count, how many times a value is appearing in your array B, you'll have to, like, you can get how many times it would have been in array A, right? For getting that much count. Is it making
Yeah.
sense?
Like n minus 1 is at least those many times it will appear, right?
Yes, at least. So that's why I'm just decreasing the count of that value by that thing, and then I'm again checking. If the count is still more, then again I'll insert.
Okay.
And since they have already told that the answer is always possible, I will always get the array A.
Okay.
Like this is not that intuitive. I think you'll have like it is, but you'll have to use a pen and paper. You'll have to write these things down. Right? How is this minimum? Like if the array, because first of all, array A was not sorted initially. So if I sort it and then I pick up the lowest element, how many times will it be in my array B? At least n minus 1 times. Now, if that element is twice in my array B, array A, now it will be at least n minus 1 plus n minus 2 times in my array B, right? So just keep decreasing these counts and each time add a new, like this element to your array. Is it okay?
What we have to add, can you
Yes.
please just repeat that?
Okay, I'll show you the code and you tell me like if it's clear or not.
Okay, it
But,
would be better.
yes. Okay, I'll show you the code once. So first of all, I'm taking n as input. Now m is the size of my array B. So this is n into n minus 1 by 2. Then I'm taking my vector A as input and I'm sorting it. Actually, this should have been B. So I'm sorting my array B. And then if the lowest value and the maximum value in array B is same, this means that all my values in array A were equal. Then only this is possible, right?
Yeah.
So is this thing clear to everyone?
Yes.
Yeah.
Okay. Then moving ahead, just count the number of times each value is appearing in array B. And now this is my answer. This is my array A. This is a map. And in map, like you get the values in increasing order only, increasing order of keys. So for each of these, C is the count and X is the value in array B. So if the count of this value is more than n minus this answer dot size plus 1, because these are the, you have already got, like if answer has 3 elements till now, so all of those 3 values were already less than X. Because right now, if if right now your value is X, currently your value is something X, earlier your value will always be less than some X, right? The values that came before X, right? Because this is a map. So if those values were less than X, you will get, like you'll have to subtract this, right, from n, because if you take minimum of this X and values that came before this X, you'll get those values only, not this X. So if the count is more than this thing, you'll decrease the count of this X by this thing and you'll push this X once in your array A. So is this thing clear now?
Little bit.
This is also A. This is
Here n is size of array A, right? And like answer dot size is the one which we'll find later.
answer dot size is only. A dot size is n.
Yes, n was, I think, the array that we have to find.
Yes. So this is that array.
Okay.
So just write a yes or no that whether or not you get the idea or not.
How is that auto loop working? Just and going it just small
Like in which level you are currently?
level 2.
I took a class yesterday. I explained this thing.
No, I meant like after for the while thing that we're checking.
Okay, this
Right.
thing. This is basically, this C is the number of times this X is appearing in your array B. So while, like I said, if this is appearing at least n minus 1 times and there is no like element in your answer till now, that is there is no element less than your this value, this X, so you'll have to push this value at least once. Now again you check, like if this is now at least C is n minus 2, then you'll push again. Now if this C is now at least n minus 3, you'll push X again. right?
Yeah.
Okay.
Excuse me.
Yes.
Yeah, I try to solve the problem very in the similar way you just showed the code. Okay. I have shared my code in the comment section. I
Okay,
just
like
joined
I
now.
won't be able to, like I explained this thing in the beginning. I won't be able to debug your code right now, but you can raise a query and tag me in it. Okay.
Okay, actually, 6 test cases passed actually. The 7 didn't pass, and the code
Yeah.
is
So
very
I'll,
similar to your code. That's why I shared. It's very similar to your.
yeah. So right now there are other people's also in the call, right? And this will get like the session is getting recorded and it will get like later it will get uploaded
Yeah,
on
sure.
YouTube.
So how should I reach to you?
Just tag one of the managers. They'll tell you. They'll help you. Okay.
Okay, sure.
Hello.
Yes.
Bhaiya, can you run that while loop for one test case?
For this loop, right?
Yes, you
Yeah.
just show us that bug thing of the template, so that it will be better for us to understand with a dry run.
Which bug thing?
That is जो template में होता है ना bug find करने के लिए.
Yes.
That
I'm
one.
not, like I'm not aware of which bug.
Okay, no
Like
issues.
he is talking about
Okay, by the way, will this be recorded?
Yes, this is getting recorded right now.
Okay.
Yes, which bug you were talking about? Some bug.
I was talking about that कि एक जो function predefine करते हैं ना खुद से template में जब बनाते हैं कि dry run करने के लिए ताकि code का dry
He's
run
talking about the debug function.
Exactly.
Okay, like I don't have it.
Okay, no issues.
Okay, like what about others people? Like other, I'm thinking like what about like how many people are there like who are feeling like no, this is really getting elongated? Like we are really stretching this. Okay, what about okay, so see what we are going to do right now. If if anyone still has any doubt, so just wait after the session and we'll try to look at your I'll try to look at your doubts once the session has ended and I have stopped the recording. Okay.
Okay,
so let's go back and let's quickly go over D. So D is an easy problem. So in this problem, we are given two arrays A and B, both of length n, and elements of both arrays indexed from 1 to n. So now we are given a directed graph where edge from u to v exists if a of u minus a of v is more than b of u minus b of v. So a vertex v is called strong if there exists a path from v to all other vertices. So basically you are given a directed graph and there is an edge between two vertices if this condition satisfies, and a vertex is strong if from that vertex you can reach every other vertex. So you have to finally output the count of how many strong vertices there are, and you have to output the number of those, like the index of those vertices or the value of those vertices in ascending order. So see, there is nothing like graph involved in, like nothing graph kind of thing involved in this problem. See, first of all, I'm given a of u minus a of v is more than, maybe more than or equals to, or more than, just more than, it was more than or equals to b of u minus b of v, right? Given this thing, if this is true, then I'll have a
edge between u and v.
Okay, thank you. So then there's an edge between u and v. So basically, if I rewrite this thing, I can write something like a of u minus b of u is more than or equals to a of v minus b of v. So I'm given two arrays a and b, right? So I can calculate a third array c in which c of I is a of I minus b of I. So now in this c, like let's say this is my array c, So this is 0, this is 1, these are the indices. So let's say these are the values 1, 2, 3, 4, 3, 2. So if this value, see, if I rewrite this also, if my C of U is more than C of V, then there is an edge from U to V. So since this 4, like this value C of 3 is more than everything, so there's an edge from this 3 to every other vertex, right? Every other vertex, there is an edge. So first of all, is everything clear till now?
Yes.
Yes, yes.
Yes.
Okay. So now just keep in mind that you're adding edges from vertex which has a more value to vertex which has a lower value. So you can reach from a vertex with higher value to vertex with lower value, but you cannot ever come the other way around, right? There is no way possible that you are able to come from a vertex which has value 3 to vertex which has a value 4. You can always go from vertex 4 to like a vertex which has a value C value 4 to a vertex which has a C value 3. So basically we can always get, like if I sort these C values, I can always go from a vertex which has the highest value of C to every other vertex, and all the vertices which have anything less than the highest value, I cannot go from those vertices to at least one vertex, that is the vertex which has the highest value. Like I can go from this vertex 4 to vertex 3. There is no way possible that I can go from this vertex to this vertex. So is this thing clear?
Got it.
So you just have to count how many vertices there are which have the value equals to 4 in this case. So generally you just calculate your array C and just count how many vertices or how many indexes have the same value as the maximum of this array C. That is your answer. Is this thing clear?
Yes, I only got stuck at this point. Like you calculated this another array C, right? Where you shifted, I mean, you have secluded U's and V's in one direction. So I did not get that, and which was why my complexity was getting O of n square. Now this is clear.
So is this clear to everyone?
Hey, can you repeat one more time? I'm still processing that.
What?
Like whole thing you just do right now. I was trying to process it beforehand and then I couldn't caught up that.
Okay. Basically, if there's a
Just
vertex
just
from,
summarize it. Just summarize it, please.
yes, there's a
Thank you.
vertex, there's an edge from U to V if my AU minus BU is more than or equals to AV minus BV. If I rewrite this, I can write this as A of U minus A of V is more than or equals to B of U minus. Okay, I think I have written this correctly. I was given A of U. Okay, I'm given this thing. A of U minus A of V is more than or equals to B of U minus B of V. So if I rewrite this, I can get A of U minus A of B of U. B of U is more than or equals to A of V minus B of V. So let's say this value AI minus BI is CI. So what I'm doing, I'm just adding edges between U to V if their C of U is more than C of V. So this simply means that I can always get from a vertex which has higher C value to a vertex which is having a lower C value, but I can never get, like I can never go in reverse direction. So I can always reach all the vertices from that vertex which has the highest value of C. And for all of the other vertices, there is always one vertex to which I cannot go, that is this vertex, right? So I just have to count all the vertices which have the highest C value. Is it okay?
Yes, it's okay.
We don't need to find like the in-between vertices, like not the max value, just like another two vertex where one is greater. From there also we can go to the lower one.
Yeah, you can go to the lower one. Let's say these are the values. There are three vertices. This has 5, this has 3, and this has 2. So you can go from both of these vertices to this, but you cannot go from this vertex to back to this vertex, right? So the definition of the strong vertex is that from that vertex you can go to every other vertex. So, but from this third vertex you cannot go to 5. So this is not a
Okay,
strong.
okay. So okay, on to every other vertex. Okay, fine. That I missed. Fine, understood. Thank you.
So I'll show you the code. So this is the implementation. In this, I'm first taking A and B as input. Then I'm calculating another array C, and the maximum value of this C is X. So just if X, like the maximum value in array C is equals to C of this vertex, then push I+1 in your answer. I+1 because these are 0 indexed and my final answer is going to be 1 indexed. So finally push, print your answer size and print your answer values. That are the answer vertices.
Yeah, understood.
Okay, someone said, think when you explain in a algorithm way manner, like you did in graph. See, I can explain you algorithms or logic if there is some logic. For the previous 3 problems, there was no logic. It was just simple maths. Like it was not simple maths, but it was something kind of intuitive. So there is no reasoning behind those problems. I cannot come up with the algorithm for this problem. So it is what it is, right? You have to just write the equation and solve it. And for the usually for the hard problems, there is something to explain. So that's the reason. So we'll go to the next problem. Okay. Yes, no, anything. I'll share all the codes. Don't worry. So,
yeah, continue.
Okay. So going to E. So in this, we are given n points, and these are integer coordinates x1 to xn. And for some integer s, we are going to construct segments first from s to x1, then from s to x2, and all the way till s to x1. Now, if x, like this second value turns out to be less than s, then our segment will look like something like x to s. So the segment A to B covers all the integer points from A to B and all the points in between. Now we define the power of point P as the number of segments that intersect, or maybe that like cover that point. So finally, FP is the power of point P, and we have to calculate what is the power of each of the points from 1 to 10 to the power 9 for each S. Like S can take only these values, x1, x2, xn. So this is also a simple maths problem. I don't know, like I think there was only maths in today's contest, but anyways, so see, first of all, we are given some x values, so I'll write them over a coordinate line. And now see, if this is like if this is my s, I'm saying that this is my s. So see, these are what my segments will look like, right? These are my segments. So this segment has just this one point. This segment has all of these points from here to here. This segment has all of these points. Similarly, this and then this. So can all of you count these numbers? Like what is the total? Like for this point, it is coming in. This point is coming in n segments. So the power of this point is n. The power of all of these points is n minus 1. The power of all of these points is n minus 2, n minus 3 this way. So we can get the count, right? It's just simple for loop and you'll have to do some math. But can all of you get these values? If my s is at this point and these are my x1, x2, xn. I'm writing these in coordinate line. Like these are sorted. So can all of you get this value? What is the total sum of my the power of points if my s is equals to x1? That is the first coordinate.
Hey, can you repeat this again?
Which part?
Yeah,
Some type of thing.
So can you repeat it? Because I didn't get it from start, please.
See, if you like forget about the input, if you have n points, so and you are saying that you are going to start your segment here and you have n points and your segments are going to close here, 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 and here. So can you count like how many times this first number or first point is going to come in like n times, right?
yeah. And
And how many times these like removing this first number, how many times all of these points will come in segment? n-1 times, right? Like this segment closed here, the very first segment. Now there are n-1 segments left, right?
correct.
So all of the points, let me draw this in a better way. So if I have my x1, x2, x3 till xn, just wait for a second, someone is joining. Okay, Ritik, have you joined?
Hello. Yeah, I have joined.
Okay, so basically, if I have x points and I'm saying that, okay, my S is pointing to this place. See, S can only take values of my arrays x1, x2, like S can be equals to one of these. It cannot take something in between. So if my S is pointing at this place, the first segment is going to be this only, right? It's going to start at x1 and it is going to close at also at x1.
Okay.
Yes. Yes. So now the second segment will go from this place to this place, right? From like S to x2, then from S to x3, then from S to x4, and this way till S to x1, xn. So can we get the power for this first point x1? What is it? It is n, right? It is coming in n segments.
Yeah.
Right. What about all the points from this, like removing the first point? What about all of these points? How many segments are they part of?
n-1.
n-1. What about all of the points that are from here to here?
-2.
n-2. So this way you can get, if your S is fixed for this place, you can get the power for each of the points. So you can get the sum of powers for all the points, right? If your S is pointing to x1, and this x1 is not actually the x1 that you get from the input. This is the sorted once you have written x1 to xn in a number line. So you can get the sum of total points, right? Sum of power of total points. It's like sum of all the power of points, right?
Like sum of what you're finding here?
Like you just said that you can get power for the first point. You can get power for all of these points. It is nothing but, let's say if there are x points, it is n x into n-1.
Okay. Fine.
If there are y points, it is y into n-2 all the way
Okay.
till here.
Yeah.
So if you add all of these values, this is nothing but the sum of powers for all the points, right?
Yes.
So now you have your answer when S is here. You have to print for everything. So now the thing that we have to do, we have to just shift our S from this point to this point, right?
Okay. Yeah.
So first tell me, for a point which is here, the number of segments. See, if my S is now pointing to this place, let me again draw the number of segments. Like the segments, how will they look like? So my segments will now look like, the first segment will go from here to here. The second segment will be like this. The third segment will be like this. the fourth segment will be like this, and maybe the nth segment will be like this. So first of all, tell me a point which was here. Will the number of segments change for that point? The number of segments that it was part of earlier and now. So will the power of any of the points from here to here change? No, right?
No,
S
no,
was
it
earlier.
won't change. It'll be present in all segments.
Yes, all the segments that it was part earlier also, right?
Yeah.
The only thing that will change is for these points, the point that belonged
Previous.
from here.
Yeah.
Yep. So how to do this? See, now it's just simple maths. First of all, decrease everything, like make all the points for here to here 0, and then since your S is now pointing here, just include those points once, right? Because there is only one set like this, and you'll have to see, now you'll have to also increase the value of this by 1 now, because earlier there was a single set, like a set which was having a single point here. Now there is a set which has a single point here. Or you can do simple maths, you can eliminate this. You don't have to, like, actually I didn't do, but you have to consider now there is a segment that has only one point, that is x2. So you just keep moving your S from this point to this point, and when you'll move this, for all the the points that are going to come, their power won't change. And for this, you'll see this will get only added once. First you'll make this like the value that you added earlier, you'll subtract everything for these points, and then you'll add it once for all of these points, because my S is here, it is going to close here, it is going to open here. So each point will only belong to one segment. But for a point which is here, when my S is at this place, this point can come in two segments. So you'll add these values twice. Similarly, when you come here, you'll add this value thrice.
Correct.
So this is the exact implementation. Let me just quickly show you. See, now there are more, like 2 or 3 more things. First of all, the implementation. As I said, you'll have to sort these values, right? I'm taking these values as in my number line. So these are sorted. So if I have to sort it and I have to output the answer in the order in which the input was given to me, I'll have to somehow maintain these values with their indices, and then I'll sort these x, right? So one of the ways is to put these in your vector of pairs. Right? So this is what I've done. I have made a vector of pairs, and then I'm inserting this xi and I in my vector, and I'm sorting it. Then I'm calculating my answer initially when my value or my S was pointing to this first x value, that is the leftmost x value. So for that, you can simply, like, how you get it? See, if this is my x0, earlier I was having all of these x as one index, now I'm doing them as 0 index. So finally it is xn. So what you can do, if your S is here, you just have to count these values, right? So just add all of these points once, all of these points. So you just have to keep adding these values, right? The difference between these. So that is what I'm doing here. So VP of I dot FF. FF is nothing but first. So first was nothing but x of I, right? So add this x value, x coordinate, minus this coordinate, plus 1. So these are the number of points between x of I and x of 0. X of 0 is nothing but you're starting, your S is pointing to which place. So S minus x of I, x of I, x of I. This way, we'll keep adding those points to your val, and val is the value that you'll get as your total sum of those power of points if your S was at x0, right? Now, in order to shift, like, first of all, like, this is also like the index for x0 is this VP of 0 dot second. So for that, this is the answer. And now I'll try to shift my starting S to like the consecutive x points, x coordinates. So for that, first remove the contribution of the current, like whatever the value that was between x of I minus 1 and x of I. So this is that. And then, like I said, you'll first add once, then for the next iteration, you'll add it twice. Then for the next iteration, you'll add it thrice. Why? See, if my S is here, all of these points will come once. If my S is here, all of these points will come twice now. Why? Once my segment will be this, and once my segment will be this. So these points are coming twice. When my S reaches here, all of these points will come thrice, because now my starting point, my ending point is this only, but my starting point can be these three positions. So this is what I have done. So first, remove the contribution that you had originally added, that is this value, and then add this thing. So finally, your answer for current index will be this val. And finally, you can print your vector. So you just have to initially find for one index of one position and then try to shift your S. Is it clear? And rest is just simple maths.
I have one doubt.
Yes.
Here you use vector of pairs to store value and its index, right? And you sorted it based on the key. Like
Yes, it gets
if you
sorted
use
on.
yeah, if you use map, will it be any difference or?
Like your implementation will change, but you can use map also. Like it will be a little bit more complex than this. You'll have to go to previous key, right? Previous index I can get with VP of I-1. In that you'll have to store it.
Fine.
Because you cannot iterate on map, right? Like this.
Okay.
Okay, is this thing clear? Just write a yes or no in the chat. What about others? Okay, so I'll move to the next problem. So next problem was also like a maths problem only. So in this problem, we are given an array A of length n, and our task is to answer Q queries. So the query is of type that given x and y, find the number of pairs I and j that both ai plus aj is equals to x and ai into aj is equals to y. So basically we are given two numbers x and y in a query, and we have to count the number of pairs such that these two conditions satisfy. So first of all, the problem statement is clear to everyone, right? Okay, so see, if you're given an x and y, we have two conditions to satisfy. Ai plus aj should be equals to x, and ai minus aj should be equals to y. So what is the value of aj that you get from here? Aj is equals to x minus ai. And what is the value of aj that you get from here? Y by ai, right? Now this, okay, I'm sorry, this should be multiplication. Now these aj, like the left hand side is equal, right? So I can compute the right hand side also. So x minus ai should be equals to y by ai. So if I multiply both of my sides with ai, I'll get ai x minus ai is equals to y. Now if I further solve this down, I'll get ai into x minus, I'll write in multiplication as dot, into x minus ai square is equals to y. If I bring this term to my right hand side, I'll get ai square minus ai times x is equals to y.
Hello.
So the generic equation of parabola is y square minus 4ac, right?
Can you repeat what you said in the last 2 minutes? Like you were stuck.
Okay, was this for everyone?
Yes.
Yes.
Okay, so basically you got this part, right? This part I can equate the right hand side. So if I equate the right hand side, I cross multiply this ai, I'll get this equation, right?
Yeah.
So this is the equation. Can you tell me what is the curve that is represented by this equation? It is a parabola, right? Yes. This is a quadratic equation and this is a parabola equation. So how many roots does a quadratic equation can have?
2.
2, right? There are at max 2 solutions possible for this equation. It's also possible that there is only one unique solution, like a parabola which just touches your axis, like at this point. And it's also possible that there is no solution. So there are 3 cases. So what is the condition for all of these 3 cases? See, b square minus 4ac is
greater than 0.
Greater than 0. B square minus 4ac is
Equal.
equals to 0, and b square minus 4ac is less than 0. Now what is b, what is a, and what is c? In a generic equation, a square, no, ax square plus bx plus c is equals to 0. This is the equation of parabola, and this is the equation that we get. So in this equation, my a is ai, my a is 1, this x is ai, and my b is x, and
minus x, right?
minus x, and c is y, right?
Yeah.
So these are the things. So for a given x and y, that is for a given x and y, that is for a given query, I can at max have two possible values of ai, right? There are only at max 2 possible values of ai, right?
Yeah.
So if there are only 2 possible values of ai, so what I can do for both of those, first of all, I'll check how many times those values are appearing, and my answer is going to be how many times these values are appearing into how many times x minus ai is appearing. Why? This is aj, right? So for a given x and y, this is my answer. But what is this ai? This ai is the root of this equation, and there are only 2 roots possible at max. Either there will be 0 or 1 or maybe 2. So now there is this equation that you have to solve. You have to find the root, and how to find the roots? Roots of the equation of a parabola are nothing but minus b plus minus under root of b square minus 4ac by 2a. So this thing, in order that, like, this shouldn't be imaginary. So if this shouldn't be imaginary, this should be more than or equal to 0. If this turns out to be 0, then you have only one unique root. And if this turns out to be more than 0, then you have 2 unique roots. In order to solve this problem, you'll also have to check, first of all, see, since our a values, like our array a has only, first of all, it has only integer values, right? So if it has integer values, we need to make sure that this thing, this under root thing, should give you a
square
integer.
root integer, yeah, it will do.
Like, so basically b square minus 4ac should be a perfect square, right? It should be more than or equals to 0, and it should be a perfect square, because if it's not a perfect square, you will get something as irrational, right?
Correct.
You'll get maybe under root 3, under root 5. So those are irrationals. So you cannot represent an irrational plus as some integer as an integer. So that thing is completely not possible. So you can skip those kinds of roots. Then maybe you get minus b, you'll get some integer, let's call alpha. This is because like b square minus 4ac was alpha square. So you took under root and you got alpha. Now there is a 2a also. A in our case is 1, so you have just a 2, right? So you have to check that upon multiplying this thing plus minus, you'll have a plus minus. Upon multiplying this thing with 2, you get an integer. Again, why? Because if you get something like 2.5, this 0.5 is not available to you in array A. Okay, so if this thing is clear, I'll show you the code, because now it's just the implementation that is left. So first of all, take array A as input. Then there are Q queries, and I have already like counted how many times each value is appearing in array A. Now this is just for like knowing whether there is 1 root or 2 roots. So this aj is just a temporary variable. So I'm taking x and y as input. So these are the equations, and I have to check this thing. Now if x into x is more than is less than 4y. So this condition turns out to be false. So I can just output 0 and continue. Otherwise, I'll calculate my val. Then I'll calculate the square root of it. And I'll check if it is not a perfect square, like a square times square is not equals to well, I'll output 0 and continue. Then these are the roots. Now I'll insert these two roots in my this set, and I'm checking that if this is percentage to be 0, that means that I'm getting integer, not decimal values. Then my current answer for current query is 0, and I'm iterating through both of my roots, and the value of those roots are nothing but the AI values, right? So AJ is nothing but x minus AI, and I'm adding count of AI times count of AJ. Now there is one corner case here. If AI is equals to AJ, then it's possible like I have counted
Twice.
it twice, right? So I'll just remove this count AI once, and finally, like for each pair, I'm counting it here also twice. Why? Because for AI, I'm counting AJ, and I'm like, if what I'm doing for 1, 2, I'm counting 2, 1 also. So this is just a one pair, 1 and 2, right? So I'll output answer by 2.
Why did you do both?
Like this is different. Okay, let me show you here. If I had 1 and 1, and my AI and AJ both can be like AI is also 1, AJ is also 1. So count of 1 is 2, right?
Yeah.
Count of 1 is 2. So what will be count of 1 into count of 1?
4.
You'll get 4. Now I'll decrease count of 1 once. So 4 minus 2 is
Okay.
2. And now this is also not correct. You have 1 and 2. Only these this is the pairs. This is the
Correct.
indices. So you'll have to
Divided.
So this is the, like, I think this is complete math. There is nothing else, no algorithm, nothing. Just maths and implementation, right? So that's it for today.
This count you have to implement, like you have to keep incrementing count also, right? Here.
No. Why? For each query, you have to answer separately.
Okay. Fine.
Okay, so thanks for joining, and bye-bye. And I'll share the codes, like the manager will share the codes and this recording with you pretty soon. Okay.
Okay. Thank you.
Okay, bye.